Linear regression line. A researcher wants to investigate the relationship between high school grade point average (GPA), which is a quantitative variable, and college GPA, another quantitative variable. Data collected show that the mean high school GPA is 3 with a standard deviation of 1.581, while the corresponding college GPA data have a mean of 2.06 and the standard deviation of 1.072. The data also show that the correlation coefficient between the high school GPA and college GPA is 0.627. Find the equation of the best fit line between high school GPA and college GPA. Use the model to predict the college GPA of an individual whose high school GPA is 3. What percentage of variation in college GPA that can be explained by high school GPA? It is noted that we assume that the researchers follow the same individuals. They recorded the individual's high school GPA and then the individual's college GPA. This is a Q to Q relationship, quantitative to quantitative. We still need to determine the role now that we know the types of the variable. There are two variables here, high school GPA and college GPA for the same individual. And so we would need to follow the chronological order, what go first. And so the explanatory variable will be the high school GPA. And the response variable will be the college GPA. If we have the data and construct the scatter plot, we would put the high school GPA in the horizontal axis and the college GPA in the vertical axis, and we will end up with a bunch of dots for the scatter plot. And this is again only if we have the data. We usually label the horizontal axis as X and the vertical axis as Y. Let's summarize the given information. The data collected show that the mean is the average high school GPA, which we now label X, is 3. From that sentence, we would write X bar equals 3. The high school GPA standard deviation is 1.581, and so the number 3 and the number 1.581 describe the high school GPA. One is the mean and one is standard deviation. So we would label S sub X equals 1.581. Next, the corresponding college GPA data have a mean of 2.06 and the standard deviation of 1.072. We label the college GPA as Y, and so we have Y bar, the mean college GPA, 2.06, and the standard deviation of the college GPA S sub Y is 1.072. The correlation coefficient between the two GPAs is 0.627, so R equals 0.627. So we summarize the 5 statistical values that were given in the problem. We can answer part A now. Find the equation of the linear regression, which is y equals a plus bx, where x is the independent variable, high school GPA, and y is the dependent variable, college GPA. X and y are the variable. We need to find a and b. Recall that with the given 5 statistical value x bar, s sub x, y bar, s sub y, and r, we can compute b. b is r times s sub y over s sub x, and we can also compute a after. A is y bar minus b times x bar. This is why we need to compute b first. But r is 0.627 times s sub y is 1.072 over s sub x is 1.581. We then use a calculator to compute this. We see that b, rounded to 3 decimal places, it is 0.425. Then we compute a. Y bar is 2.06 minus b is the number that we just computed, 0.425 times x bar, which is 3. Put it in a calculator, we will get 0.785. Now that we have both a and b, we can write the least square or best fit line. Y equals a is 0.785 plus b is 0.425 and then x. Always set up the computation first before using a calculator, and clearly label the 5 statistical value with their corresponding symbols: x bar for the mean, y bar for the mean, s sub x for the standard deviation, s sub y for the standard deviation, and r for the correlation coefficient. Remember that y predict the college GPA. 0.785 plus 0.425, and x represents the high school GPA. For part B, use the model to predict the college GPA of an individual whose high school GPA is 3. What this means is that we need to find y when x is 3. Y equals 0.785 plus 0.425 times x, but again, x is 3, so we replace x with 3. Put this in a calculator, we see that this is 2.06. What this means is that if an individual has a high school GPA of 3, we can predict that their college GPA will be 2.06. What percentage of variation in college GPA can be explained by the high school GPA? The question about the percentage of variation in the response variable that can be explained by the explanatory variable, percentage of variation is simply the square of the correlation coefficient. The correlation coefficient is given 0.627. And so the percentage of the variation is r squared. But again, r is 0.627. We just simply take r and square this. This is 0.393, or roughly 39%. This is the percentage of the variation.